Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 36, Gases Part 2. Here are our objectives for today's video. Pause here. So the goal of this video is for you to be able to derive relationships starting from the ideal gas law between any two or three variables of the ideal gas law. I'm going to walk you through example number 4, and then it's the same process for example 5 or 6, and also for really any relationship of this variety. So there's more than one way that you could do this. I'm just going to show you the one way that I consistently see students be able to do correctly. So I'm starting with PV equals nRT. The sort of process I like to do is I like to take the variables and put them on the right, on the left. And so here, my variables are volume and temperature. And then I take everything that's constant and I put it on the right. Everything else. So I start with PV equals nRT. I only want volume and temperature on my left. So I end up with V over T is equal to NR over P. So I divided both sides by P. I divided both sides by T as well. Now from there, what you could do is you take what is on your left and you can make it equal to a constant. So in this case, it could be V over T is equal to, I'm just going to use a sort of random constant. I could call it A, call it C. It doesn't really matter. It's just a constant. But then in terms of actually doing problems, it's probably going to be easier if I just show it. V1 over T1 is equal to V2 over T2. So I've just mathematically derived this. When I say 1 and 2, I really mean initial and final. So initial volume over initial temperature is equal to final volume over final temperature. And so the goal would be that you could derive this relationship here just from PV equals nRT. Pause here. So what we just derived in the last example is mathematically equivalent to what's written here. This is Charles's law. Charles's law predated the ideal gas law, meaning that that process that we just did was not the way that this law came about experimentally, but it just makes it a whole lot easier for you to remember, because for Charles's law, Boyle's law, and Avogadro's law, I'm not going to be providing those equations on a assessment of this sort. So you will need to be able to derive them from PV equals nRT, which is typically not a problem. Most students are very, very good at doing that. Pause here. I'm going to work through this one a little bit faster. It's the same sort of process of what was on the prior example. So we already have it set up such that the constants are on the right and the variables are on the left. So you could just make it PV equals, we could call it K, you could call it literally anything else. So the difference here, this was a fraction and this was its multiplication. So this is a direct relationship, whereas this relationship that we just derived is an indirect relationship. Pause here. So what we just derived in the last example is called Boyle's law. Pressure times volume is equal to a constant, or for most problems, you're more likely to use P1 V1 equals P2 V2. Again, Boyle's law predated the ideal gas law, but it is just very useful to be able to derive it mathematically. And then we have one more very similar. Pause here. So once you get it set up with your variables on your left, then you could write this either as v is over n is equal to some constant. I'm just going to call it b here, but again, I could call it literally anything. Where volume over number of moles is equal to second volume times second number of moles. This is a direct relationship. It's here. So Avogadro's law is mathematically exactly equivalent of what we derived in the last example. Volume is equal to a constant times number of moles, which just means that as number of moles increases, the volume increases, which logically makes sense. Right, that is all for tonight's video. Thank you so much for watching and have a great night.